All right. Well, big welcome to all families, students, classrooms, and science lovers who are joining us virtually to take part in this special event for Science Literacy Week. My name is Joe Grabowski, and I'll be your host for today. I'm with an organization called Exploring by the Seat of Your Pants. We bring science, adventure, exploration, and conservation live into classrooms across North America and beyond through virtual guest speakers and field trips. Head over to exploringbytheseat.com. We've got over 50 live events this month, starting the school year, and a whole big group of events, including space exploration and more coming up in October. So, as you may already know, this week is a very special week. This is a week where organizations from across the country come together to spread science literacy across Canada. It is Science Literacy Week. From September 20th to the 26th, libraries, museums, science centers, schools, not-for-profits, they're all coming together to celebrate science and for a special theme being climate. Canada is a country that's filled with different climates. We've got long, harsh winters in the north, mild and rainy stretches along our coasts, dry flatland and varied temperatures in our prairies, and heat waves and snowstorms along our southern border. These different climates define Canada's regions and influence the people, plants, and animals that live within them. So stay tuned after our main event to learn how you can participate in Science Literacy Week. I can hear a little bit of beeping in the background, and what that means is we've got an awesome group of classrooms joining us from across North America today. We have camera classrooms joining us, and they're going to be asking some live questions. And I want to give a quick shout out to our YouTube crew who's joining us live. Let us know in the comment bar where you're joining us from. And of course, send us in some of your questions there and we'll work them in at the right time. So joining us for our special event today as we dig deeper into this year's theme is climate specialist, Dr. Aldona Wiacek. So Dr. Wiacek is cross-appointed in the departments of environmental science, as well as astronomy and physics at St. Mary's University in Halifax. So I'm going to bring her in live with us right now. Hello, Aldona. How are we doing today?
Great.
All right. Excellent. Well, listen, it's so great to have you joining us live today. I think you might even have a crew joining us out on the East Coast as well. So we'll definitely make sure that we work in some of their questions. But we're going to start off with a little Q&A action between you and I right now. So, you've spent your career studying the environment and climate. We'd like to know why. What made you so interested in learning more about our changing climate?
Right. So you do have my slide there. So the answer to that is kind of one word, and it's the word that climate studies are interdisciplinary. So this you're not meant to take in every word of this slide at all, and I'll come back to it shortly. But I really grew up in a different time than, the young people tuning in today. It was before there was such a thing as a climate emergency. It was before Greta, but I was always interested in how the world works. And, in high school, sorry about middle school is kind of a blur, but in high school, I remember like physical geography and learning about the ozone layer. Just 5 years after the Montreal Protocol came into effect for protecting our ozone layer. And I like these topics a lot. It was very relatable to me, but I discovered that you can't really go and study that at university back then. So right now, interdisciplinary fields like environmental science at St. Mary's University, shout out, St. Mary's is ranked 4th highest in undergraduate education in Canada. So we have interdisciplinary programs now where we didn't have them when I entered university. And that's what I honestly would have done if that was available to me now. And I always wanted to do something useful. So because of that, my options back then, I liked science, I liked math, I went into engineering. And towards the end of my degree, I came across remote sensing, which is studying the Earth by light, which I'll talk about more later. And at the same time, climate change became a thing. 1992, United Nations Framework Convention on Climate Change. And so I was hooked from then on, looking at the Earth from space and doing something useful for the world. And because I had a hard time committing to like physics or chemistry or biology or whatever, so here's climate science in all its glory. These are climate drivers, which in today's lingo might be the climate influencers. So you got your sunshine, you have your infrared leaving the Earth, you have aerosols, clouds, ozone, and greenhouse gases, and the surface. And all those things interact to give us the climate that we have. And I find that you need to know a lot of different things to study this meaningfully. And then the second slide is that there's always cool maps and cool graphics in my field that are, you know, part of something that's real, or that represents something that's real. And I just love looking at cool graphics and maps.
All right, excellent. I like that term, climate influencers. I think that's something everybody, the social media savvy, can understand what an influencer is. Very cool. All right. Well, I mean, we know about all kinds of different jobs, you know, policemen, firemen, and such. So what is an average day look like for you as a climate scientist? What is your work all about?
Right. So you have a slide for that, which shows that there really is no average day for me. So my work has to do with studying air quality and climate change by looking at gases in the atmosphere. So these are both examples, left and right, of something I could be doing on a given day. So I could be looking at maps of nitrogen dioxide over North America that's remotely sensed. And, you know, you've got Nova Scotia there. Everybody can, on the East Coast anyways, can point to Nova Scotia. And so there's a lot of pollution upstream from us, and it travels to us. And I'm interested in that. We have a paper out on that recently with a graduate student of mine. But I could also be doing field work, which is what the right image shows. So we are here in this picture with some students, and we're doing measurements from Halifax Harbor to George's Island. So I could be looking at a computer, making measurements outside, or I could be answering email, or I could be teaching. Everybody knows that university professors teach. That's the best known part of our job. But there's also this huge research component and service to community. And when I say service to community, it's like talking to everybody today. That's one example. But when I say research, I mean less library research, but more like create new knowledge for the library type research, because we're looking at things that haven't been studied before, relating to, in my case specifically, so atmospheric composition, we say, which is the gases that make up, and aerosols that make up the atmosphere and have their influence on air quality and climate. So a lot of what I do concerns remote sensing. And then the data that we gather and the studies that we do, you know, the hope is that we are influencing and informing policy on air quality and climate change regulations. Ooh.
Make sure I get my mic there. I think that's the best kind of job, a job where every day can be different. And you know, you some days you might be inside at a computer, which might not be the most fun, but I think those days in the field probably make up for it, and then some.
Days in the field are very, very stressful. So it's a good balance to be able to come back to the shelter of your computer.
All right, excellent. Well, there is a link between air quality and the climate. So can you share a little bit with us today? What is that link between air quality and climate?
Right. So here I will talk more directly to the slide. So this is a picture of a very, very smoggy city, and I don't know which city exactly it is. And this brownness of the air is very unnatural. And so you have sunshine entering this city, and that's the yellow arrow. And then you have heat. After the sunshine is absorbed by the earth radiates heat, like all things radiate heat. And air pollution will interfere with this natural process of sunshine in, heat out. And so some air pollutants are actually greenhouse gases, so they will actually interfere with the red heat arrow trying to cool off the earth. Actually, an example of a greenhouse gas is an ozone, which is, it's good in the stratosphere way up high. It's terrible near the ground because it'll destroy your lungs, but it's also a greenhouse gas. It also has the ability to trap heat. And then another connection that's actually more visible here in this is that if you clean up this mess, you're going to make the world a brighter place. So you're actually going to make the world a hotter place. But it's no way to control climate change by making the world dirty, right? And that's not the umbrella that we want to have above us to reduce the heat input. So, you want to clean up greenhouse gases by eliminating fossil fuels, by eliminating this whole soup of chemicals. And you have to understand that in doing so, you are going to make the world a little bit warmer of a place. And so this pollution has been masking the effect of greenhouse gas accumulation by giving us a bit of a breather in terms of cooling us off, but not a good thing, because the air like this you don't want to breathe.
All right. Well, very interesting. I hadn't heard that before about the, that the pollution is kind of masking a little bit of what we're seeing now. That's, yeah, very interesting connection that I hadn't thought about before. So when you're conducting your research, you mentioned already a technique called remote sensing. So that might be new to a lot of those who are tuning in with us today. Can we talk a little bit about remote sensing?
Definitely. So I have a slide for that. So in one word, remote sensing is fun. This is specifically satellite remote sensing. So right now there is, this thing is called the A-train. Scientists are nerds, and they think that all these satellites flying information is like the A-train from a show that actually I never watched, but I don't know if any of the kids will be getting the A-train who are tuning in today. Maybe their teachers are. But anyways, you notice they have these kind of cones and stuff all coming out of them. So that's meant to represent how they're collecting various kinds of light that is transmitting information to the satellites about the planet underneath. And actually, so remote sensing is using light broadly defined. So it could be visible infrared, it could be ultraviolet, using light to detect things at a distance. And so your eyes are remote sensors. You're seeing, the reason you see the wall or me or whatever is because photons, light beams, have gone into your eye, and your eye and brain have processed this. And so satellites in space collect different kinds of light that also carries information about the planet underneath. And this is just one configuration to fly up in orbit and look down. You could actually remote sense from the ground and look up, and the light source there would be sunshine. There's an endless array of configurations that you can use to try and gather information at a distance. What you need is some telescopes, like these, some way to gather your light. And then the atmosphere below changes the light that enters your telescope, and that's where your information comes from. One of the most accessible examples of remote sensing, I think, so I said your eyesight already, but you could just be flying in space and taking visible pictures, and then you're imaging clouds underneath you. That's remote sensing, because you're not there touching the cloud. You're seeing it all from a distance. But I have the next slide, which is pretty cool, and that's remotely sensed carbon dioxide. This isn't purely an image from space. It's a mixture of space measurements and also model blending. But we have definitely satellites in space that detect CO2. And so you can clearly see here that this is today. It's from a website that I really love called earth.nullschool.net. It's in the bottom right corner. Whereas the other one was windy.com, which you can also switch to look from meteorological parameters like pressure, temperature, to chemical parameters like carbon monoxide and particulate matter. But anyway, here, just at a glance, you could see that the northern hemisphere has browner, more brown colors, because we're still coming off of summer, so we have less carbon dioxide, and the southern hemisphere has slightly lighter shades of yellow-brown because they're more in their winter, or just, about to end their winter. And yeah, this is something that we routinely measure and study from space with the miracle sort of remote sensing.
All right. Well, it's really cool to think about those eyes in the sky, always kind of looking down, and all that data that can be gathered and tell us things about our planet.
And that anyone can go to see it at this website. It's at your fingertips. You just have to know.
All right. Very cool. Well, you also mentioned that you were interested in human impact on the atmosphere. So what are some actions that we can all take to help reduce air pollution?
That's a great question. You hear so much about this now. So personal actions are really important, turning out your lights and walking instead of driving and not flying as much, and maybe reducing how much meat you eat or what kind of meat you eat. Those are personal actions, and they are important because they help us establish a culture of energy awareness and energy conservation. But at the same time, what we really, really need is to pressure our politicians to implement actions on the scale of a whole society. And so this is a picture from a second-year textbook about a redesigned energy grid with renewable energy inputs from solar cells and wind turbines and a biomass burning plant. And we need this kind of society scale change to taper down our fossil fuel consumption and ramp up our renewables like wind, solar, and hydro, because all this stuff about net zero by 2050, no net carbon dioxide emissions by 2050, that's very much necessary to prevent dangerous anthropogenic climate interference, as it's called. So to prevent temperatures rising by more than 1.5 degrees. Now, as a school child who can't vote, it's very hard to pressure your government to take any sort of change, but just get ready, because before you blink or count to 3, you'll be there voting, and these are the kind of things that we need.
All right. Perfect. Well, we're getting to the part what I think is the best question of them all, because we are all about inspiring that next generation of scientists and explorers. So what advice would you give to young students, like ones who are joining us today, that are interested in our climate and would like to keep learning more about it?
Ooh, so everyone's different, right? So I have a list of resources, for example, on climate, weather, and oceans from CMOS, the Canadian Meteorological and Oceanographic Society. So that's our national organization of scientists, but also industry members who are concerned with all things meteorological and oceanographic. And that includes weather and climate and air quality in Canada. So you can start by getting yourself educated and informed. My advice would be that you don't have to be a professional scientist to make an impact in this area, for sure. That's what I am, but you don't have to be a professional scientist. You can get involved meaningfully in many different ways, but I would advise you to keep studying science as long as possible in high school and also at the basic university level, because that's going to help with just about everything that you do. And critically, it's going to help you with the ability later to distinguish information, good information from bad information.
All right. And we talked a little bit at the beginning about climate influencers, and maybe that's what we need our students to become, influencing people with their positive actions to make differences in their own lives and hopefully inspiring others to do the same. All right, very cool. Well, thank you so much for that live Q&A session. Now I'm going to turn things over to some of our live classrooms. So if you're tuning in live via YouTube, please send in some questions there. I'll keep an eye out for those. But for now, let's talk to a few of our live camera groups, and let's get some of their questions in here with us. So let's see. Let's start off in Belleville, Ontario. We have Mrs. Hannafin's group joining us. I'm going to bring them into the call now. There they are. How are we doing today?
Good, thank you. Great presentation. Thank you so much. We have a question. Would one of you gentlemen like to ask a question?
I like the thing about
the remote sensing.
Remote sensing, that's the word. Yeah.
Did you have a specific question about that, or?
No, I thought it was interesting though.
Can you speak specifically for our class? We're studying forces in nature and natural disasters. Could you take a minute and talk about how you feel they're being impacted, particularly in Canada, natural disasters, and how that's a result from our changing climate?
So, 'tis true. I mean, that's the basic statement there, that natural disasters of the heat related like fires, and also active weather related, so flood type disasters, they are on the rise. The exact sort of one-to-one correlation between human emissions of CO2 and natural disaster frequency is something that's still being studied, but it's happening. That extreme events are becoming less extreme. Something that used to be a 50-year timescale event is no longer a 50-year timescale event, and you might see it returning, in 10 years. The new assessment report that just came out on the physical science basis underpinnings of climate change has, a whole slide deck on what we understand, and that's one of the reaffirmed understandings. It's not an emerging understanding. It's a confirmation of this expectation that if you put more heat in the climate system, it's going to roil harder, and that's going to lead to more disaster scenarios involving weather.
All right, thanks for that great question to kick us off. We're going to head to another spot here with Mr. Shattuck's grade 6-7 class who are joining live. How are we doing, 6-7s?
Do you know how much heat goes up?
Okay. So I think how much heat goes up in like a year or daily? What are you thinking?
In like a year.
No.
Actually, I have an answer for that because I was just calculating it for another presentation that I'm giving. So, well, it's kind of an answer. It is a lot. So how much heat comes down first from the sun is 1,000 up like right above the earth. The solar intensity is 1,370 watts per square meter. A watt is a joules per second. It's a measure of energy. And those of you who have seen an old light bulb that is an incandescent light bulb, it produces 100 watts of energy, so 100 joules per second. So the sun is as bright as 13 of those, right? 1,300 watts in every square meter of the earth. So square meter is, 3 by 3 feet. And so that's what comes down. And what comes up has to be roughly the same, or else the earth would start really heating up, or it would cool down. If we had more light leaving, that was the red arrow in the one slide I showed. So if we had more light leaving than what was coming in, the earth would cool off. So it's 1,370 watts per square meter, and that's joules per second. So in a year, you would want to multiply that by joules per second times 3,600 seconds per hour times 24 hours per day times 365 days per year, and you'd have your number of how much the earth has to get rid of in terms of energy.
All right. I wish I was quicker and had my calculator handy, but that could be some good little homework for our class to figure out is how much heat we do need to remove. And it looks like you might be crunching the numbers on your end as well. I have a feeling it's going to be a big, big number.
It's a huge number. It's like 400 billion in every joules in every square meter in a year.
Okay, there we go. Very, very cool. And another reason why maths are so important, and why sometimes in school when you're like, oh, math, but you really need it for science jobs in the future. It definitely comes in handy. All right, let's head out to the East Coast because we have a few classrooms in Nova Scotia in Halifax joining us. So we'll jump over to Miss Drake's class first, some 5th graders. And I think they've switched to a computer with a mic. I think we've got them here live. There we go. All right. I think there's going to be a little feedback just because the two are running, but I bet you if you pause one of them, we'll be able to get the question in.
Hi, is that better?
Yeah.
All right.
Okay, great. Yes, shout out to Katie's mom. We just wanted to say a little shout out there. We had a student asking about getting a more information on how exactly the satellites work in the atmosphere there in terms of like gathering the lights. Could you speak a little bit more on that?
Yeah, so satellites up in space, in many ways, they're like your camera. They gather, they point in a certain direction. So a lot of those satellites that I showed, a lot of them were looking almost straight down, and they have what's called collecting optics. That's a bunch of lenses, just like your camera has some lenses that focus the light onto a detector. And inside the satellites, there will be a detector that's going to convert the light into voltages. And then a bunch of engineers will figure out that a certain number of volts means a certain amount of watts per square meter. And then a bunch of other scientists will come in and help convert that information to an actual gas concentration. So it's a really good question. How do you get from like a picture to a gas concentration? And the answer is that it is complicated. It's complicated to explain in this kind of a setting, but people work on the mapping from, light to volts to watts to gas concentration, using all kinds of knowledge that we have about which gases in the atmosphere absorb which types of light, whether it be ultraviolet or visible or infrared. I hope that helped a little.
Yeah, absolutely. Very, very, very cool. I think we've got a second classroom joining us out on the coast there. Another grade 5 classroom with Mrs. Dugwe Mayat. So let me see if I pop them in, if they're able to unmute for us. Let's see. There we go. Can you hear us over there? No, maybe not. If you're able to hear us, our second class in Halifax, if you want to type a message or question into the private. Oh, there they are.
Yeah.
Hey, everyone. How are we doing?
Hi, good. You?
Good, good. Thanks for joining us today.
Well, thank you. So this is very, some interesting information we're hearing. Did anybody have any questions at all? Okay, what do you have for a question, Ian? Do you want to just come here? Because I don't know if they'll be able to hear you. No. Oh, I thought you had your hand up. Okay, so Paul, do you want to come and just going to get Paul to come to the mic? And we have Paul here, so speak.
How much do you think the climate change will grow over the next few years?
Okay.
Joe, did you get that? I didn't hear it.
Yeah, he's wondering how much do you think climate change will grow in the next few years?
Yes.
How much?
So, if we, don't curb our greenhouse gas emissions, then temperatures will continue to rise by several degrees now it's several degrees over the global mean of the planet. So, on a winter day in Halifax, you definitely would want several degrees warmer and you wouldn't be unhappy about that. But we're talking about the whole planet warming up by several degrees. So like 3 to 5 in the next 3 to 5 degrees Celsius in the next 50 years if we don't do anything about it. And all the big commotion you might hear on the news about carbon taxes and reducing greenhouse gas emissions is to reduce our emissions to almost net zero emissions of carbon dioxide by 2050, which is only 30 short years away. So that's the kind of action that's required. And in that case, we will have a warming of about 1.5 degrees global mean, which is more manageable in terms of the kind of active weather or extreme weather that it produces. And it's not just weather. We have to be clear that when the climate changes, also other things change, like the amount of rain we get, and that affects our ability to grow food. And so that's the really serious motivation for keeping our climate as stable as possible, so that we can keep our food production as stable as possible. Good question.
And I think that's what, makes this such an interesting field, is a lot of this science is happening in real time. We're trying to find out just what is driving these changes and how quickly it's happening and such. So I think that's what makes it such an exciting, dynamic field, is we're learning so much right now about our planet, and still trying to find a lot of answers.
Yeah.
All right. Belleville, Ontario, grade 9 science class, hanging out with Miss Lynch. Let me pop them in there. How are we doing, Belleville?
We're doing well. Thank you so much. I'm going to let Enid ask the question here.
Okay, so right now we cannot vote, but we are trying to make a public service announcement. How can we get the attention of the public from your experience?
How can you get the attention of the public from my experience? Is that what you said?
Yes.
Well, so I don't have a lot of experience in getting the attention of the public. I'm a nerdy scientist. I am no Greta. Greta seems to have got a lot of attention. So perhaps we could take a page from her book. Certainly peaceful demonstration gets people's attention. I can understand and imagine how frustrating it would be when you can't vote, but you're passionate about an issue. You could still contact politicians and try and get anybody's attention who will listen, because it's certainly the kind of problem that requires the attention that it often isn't getting. I wish I had a better answer for you, but it's not really my area of work.
Well, it's a tricky thing. I think a lot of surveys and studies show that changing someone's mind isn't easy. It's a very difficult thing to do, and I think the worst thing that you can do is kind of belittle someone's opinion or talk down to someone. So I think it's kind of strange, but listening to what other people have to say, and then yeah.
It's not my field, but that is also what I've read. I've read lots of articles like, why don't people believe this? It's so basic to me, right? But like, people's minds are made up based on emotional considerations before you say really anything to them about facts. So I would second what you said, Joe, that rather than beating someone over the head with facts or guilting them into why don't they see the bigger picture, that we try and first connect with them and understand their values and appeal to their values, which are often, their values aren't that they hate the planet. That's not what they would say if you talk to and listen to them. Yeah,
absolutely. Okay, well, great questions from our crew so far. We're going to take a little pause in the Q&A portion, and I'm going to bring in Melissa Roy to join us. So Melissa is Communications Advisor at the Natural Sciences and Engineering Research Council, and she's going to give us some more information on Science Literacy Week, and then show us a little bit about how we can participate. So I'm going to pop her into the conversation now. Hey, Melissa, how are you doing today?
Good. How are you, Joe?
Good. Well, listen, I'm going to let you take over for a little bit, and then we'll pop back in.
Perfect. So thank you very much for having me today. I'm very happy to be here to tell you more about Science Literacy Week and how everyone can participate in this week. So as Joe mentioned earlier, Science Literacy Week is happening this week, and there's events happening all across Canada up until this Sunday, September 26th. So Science Literacy Week is about how we as students, families, can explore and enjoy the diversity of Canadian science. So during this week, organizations come together to highlight the books, podcasts, movies, events that highlight the science in our everyday lives. So I will now share my screen to present to you some of the key pages on the Science Literacy Week website that you want to have a look at to make sure you make the most of your participation. So you will first want to visit the events page on the website. So this is where you will find all of the events happening during Science Literacy Week. You can also use the different filters to find events that are happening in your area in the location field. You can also look through the dates field to find events that are happening on a certain date. And you can also look through the tags list to find events that have a common theme with your interests. As some events are happening in person, a lot of them are also taking place virtually online. So make sure that when you're doing your search, you have the online events box checked right over here. The next page you will want to have a look at is the posters page. So on this page, you will be, apologies for this. On this page, you will be able to download for free the Silent websites, the Silent posters for this year. So on the theme of climate. The posters are produced by Microfiche in collaboration with the Natural Sciences and the Engineering Research Council of Canada, as well as Environment and Climate Change Canada. So each of the 6 posters you will download by clicking Download Posters is beautifully illustrated by a Canadian illustrator and provides educational information about Canada's climate. And if you scroll down the page, you will also be able to download the posters from previous years of Science Literacy Week on different science themes as well. And Science Literacy Week would not be possible without the help and the engagement of all of its partners. So a big thank you and a big shout out to all of their great organizations for their role in spreading science literacy in Canada. So on this page, you will see the entire list of partners for this year's edition of Science Literacy Week. And finally, there's another date you will want to add to your calendar, which is actually tomorrow. So Wednesday, September 22nd, when you will be celebrating National Science Reading Day. To celebrate, simply dedicate a period of your day to read about science. Visit your local library to pick up a book on a science topic that interests you, or a topic you want to know more about. And make sure you note your reading list and take pictures so you can participate in Owl Kids contest. There are lots of cool prizes to win, so I would encourage you all to have a look at this contest and pick up a science book tomorrow.
All right, perfect. Well, I'm going to leave that link up there for a little bit there so that we know where to go. I mean, there's just so much that's going on. Those posters look incredible. I think some of those would look good on my wall here when I'm presenting. And then, yeah, those giveaways look like a great opportunity as well. So great way to bring some science, even from your local community and see some really interesting things. So that link's up there one more time for you. I'll leave that up there for the next minute or so. But I'm going to bring Aldona back in here because we just talked about books. So I'm wondering if she maybe has a favorite book or book suggestion that she could share with us today. So let's pop her back into the conversation.
Hello, I'm back.
All right. What do you got for us?
Well, so as a kid, our house wasn't air conditioned, so I used to go in the summers and like hang out at the library. And I started out my journey into science by looking at large coffee table type books with lots of glossy pictures about, it was astronomy, because like there was no remote sensing of the planet in 1990 in 1990 when I was doing this. So these days I probably would be looking at like large glossy books of remote sensing. And then I have to be really honest that I actually read like a ton of science fiction. See, I've kept only a few of these books. Here's a super dorky Star Trek book that I love to bits and pieces. You know, science fiction is not a bad way to like get a hook into science because it excites your mind about what's possible. You know, if you want to just explore a topic though, these days, Wikipedia is an amazing place to start exploring a topic. It is curated. Sure, you can't believe absolutely every last word on Wikipedia, but it is curated by enough people that for the most part, you're going to get the general picture and at least the references of where you should go next. And And if you can support Wikipedia with a small donation, okay, not you kids, but maybe parents, like I pay like $3 a month as, a small donation to Wikipedia to keep it going, because I consider it this incredible resource that, did not exist 25 years ago. And for the older kids, I actually do have a book, but it's not about science facts. It's called Merchants of Doubt. It's how a handful of scientists obscured the truth on issues from tobacco smoke to global warming. And it is a book written by a historian, so there'll be no equations in it. And it's about how data can be manipulated and how organized campaigns of misinformation can be produced to make you think that, cigarettes don't kill you, acid rain doesn't destroy the soil, and that greenhouse gases don't cause climate change. It's a bit scary, but I think it's like required reading for anybody looking to learn about critical thought, and especially critical thought as applied to science. We are overwhelmed with data, so you have to learn to make sense out of it yourself. This isn't to say that you should do your own research always and like become an expert in something. You're not going to become an expert in remote sensing unless you spend 20 years on it, right? But you should become an expert about judging sources of information so that you know immediately that you're in a reputable source of information area and that these are people that you can trust, because ultimately we're going to have to start trusting people. Like I trust my mechanic. I don't know how cars work, and that's kind of how it should be. We're not meant to be experts on everything. We just need to know where to go.
Yeah, I think that's a great book selection, and you're so right. That's what we want our students to become, as critical thinkers who can do some research and find good information from good sources. So great option. And hey, science fiction, a lot of ideas from science fiction books. Some of that technology has come to be. So very, very cool. All right. Well, I wanted to make a huge shout out to our classrooms who joined us today. Thank you so much for your great questions and for joining us during Science Literacy Week. A huge shout out to you, Aldona, for joining us today. It was great to have you with us and to share a little bit about the really cool job that you have and you're able to do, making that connection between our air quality and climate. And I want to remind everybody again to make sure you take some time, visit scienceliteracy.ca this week, find out about events that are happening around your communities. There is so much to choose from, in-person, online, events just like this one. So thank you so much for everybody for joining us live today.
Thanks, Joe.
All right. Thanks, everyone.